Thank you, Markus, and welcome to security updates in AUTOSAR 25-11. My name is Michael Schneider, and I'm the speaker of Working Group Security. Today, I've brought two topics with me to show to you. The first is improvements in the adaptive AUTOSAR crypto stack, and the second are AUTOSAR security events, improvements, and extensions. So let's start with the first one, with the adaptive AUTOSAR crypto stack improvement. The adaptive AUTOSAR crypto stack is a functional cluster that provides interfaces to access cryptographic operations for key management and for certificate management. And as such, it is used to implement use cases that rely on cryptography, like secure communication, for instance, based on secrecy or TLS, to implement diagnostic access control, for instance, using UDS services 27 or 29. But it is also used by OEM-specific key management applications to manage keys. On the right-hand side, you can see the architecture of the functional cluster crypto. In the middle, you can see the functional cluster cryptography. And in this example, we have three providers: an X509 crypto provider, a software crypto provider, and an HSM crypto provider. And we can see on the lower part that they map on two different resources. So the operating system can provide a file system, which can serve as certificate storage and key storage. But on the other hand, you can also have a dedicated HSM if your hardware supports that, which can also act as key storage. And we can see here that the functional cluster cryptography is very flexible. It allows to implement variants of cryptography implementations, being a DOS, being the HSM, or even other solutions. On the top part, we can see users of the cryptography functional cluster. This could be adaptive applications or also functional clusters using our crypto to manage their keys. And we can see that they both go first into an access control layer, which makes sure that the application has only access to the keys that it for its own needs and cannot access keys for other functional clusters, for instance. The functional cluster cryptography is already available with AUTOSAR since, I think, 1711. However, we have now received feedback from real-world projects in the past years, highlighting challenges with the current design, and we have taken this feedback and addressed it with the AUTOSAR release 25-11. We can see example improvements in the adaptive crypto functional cluster. The main focus was improving the application developer experience, meaning that we have improved the APIs with simplified usage. We've also standardized algorithm identifiers, which makes it easier to identify and use cryptographic algorithms. We have also taken into account the limitations of hardware security modules, improved X509 certificate management, making it more flexible with regard to validation and certificate management. And finally, we've also taken into account the resource consumption of the functional cluster crypto and try to improve performance here by reducing the need for dynamic memory allocations. With this, I would like to go on to the next topic that I've brought with me, the AUTOSAR security events, improvement and extensions. So let's dive in here. I would like to start with a brief explanation on what is automotive intrusion detection. It's a quite complex area, and we can start on the lower left side with bullet point 1, IDS sensors that are distributed in the vehicle that are highlighted here with these light blue boxes. These IDS sensors monitor resources in the vehicle and raise security events in case something suspicious is observed. One example here could be the SecOC module as IDS sensor, which observed that a SecOC secured message could not be verified, so it raises the security event SecOC MAC verification failed. This security event is raised towards the IDSM, the IDS manager, shown here as gray boxes. The IDSM qualifies these security events, so it filters out noise, and it stores them locally or forwards them on the network. If they are forwarded on the network, they are received by the IDSR, the IDS reporter, which in turn forwards these security events to the SOC, the Security Operations Center, where security experts receive these events, analyze them, and decide about countermeasures. In AUTOSAR, we already support a good chunk of this whole workflow. We do have IDS sensors with security events. We do have the IDSM. We do have a standardized protocol to transport security events within the vehicle. But again, we have received feedback from real-world projects that the IDS sensors could be improved, and that's what we are attacking right now. You can see that we have created an AUTOSAR security event working group to improve the security events. You can see here that we have a good number of OEMs and tier ones participating in this working group, and it works like this. First of all, the group collects IDS requirements from all stakeholders, and we discuss which are the biggest pain points, which topics should be prioritized, and we decide which topics to address for the current release. In the next step, we define, we go through every step, through every topic one by one, and discuss which information we would like to have for a specific technology. So, for instance, let's use TLS as an example. We're taking the TLS standard, we're discussing which information we would like to collect, and we define that, not taking possible limitations in AUTOSAR into account. In the next step, once we have agreed on which information to collect, we are approaching the working group that are owning the respective documents. So for TLS, this would be the working group in vehicle communication. And we discuss with them what we would like to have, and we align with them what is possible from AUTOSAR perspective and specify the security event together with them. In the end, we have, of course, the release. So once this is done, we go back to start for the next release and start over again. Looking closer at the release, we have also introduced a new document, the technical report on security event specification. This document, which was already released last year for the first time, contains the complete AUTOSAR specification of security events, on the one hand in a short form based on the list, but also in a more detailed fashion, including all context data for all security events provided by AUTOSAR. We can see the technologies that we are now supporting in AUTOSAR and that the security event working group has addressed so far. On the left-hand side, I'm showing you security events that were newly defined within the working group. So we're talking here about TLS and Secure Update, for instance. These two technologies were already introduced in 24-11, so last year. This year, we have introduced new security events for DoAP, for AUTOSAR Identity and Access Management, and for Secure Boot. However, the group has also revisited already existing security events and tried to improve them based on market feedback. Technologies are shown here on the right-hand side. We can see here UDS, for instance, which was also already addressed last year. And for this year, we are improving security events for firewall, for Ethernet and TCP/IP, for SecOC, and for X509 certificates. Generally, I think we are making good progress here, but we do have still some topics open for 2611 for next year. Finally, let's summarize. I think AUTOSAR provides a wide variety of security controls that can help you in securing your ECU and your vehicle. And AUTOSAR also maintains its security control landscape and listens to the industry, listens to market feedback, and addresses these pain points. This is exemplified by the two topics that I've shown today, by the improvement of the adaptive AUTOSAR crypto API, focusing on application developer experience, and on providing efficient intrusion detection by providing a high-quality security event baseline. That's it. That's my update from security. Passing on to Piero. Thank you.